keywords. So in this video, we'll be talking about a function provided by Pandas that is called a Concatenate. Uh, Pandas provides various facilities for easily combining together series or data frames with various kind of set of logics. For the indexes and relational algebra functionality in case of join and merge type operation. In addition, Pandas also provides utilities to compare two series or data frames and summarize their differences. In this video, we will be particularly talking about concatenate function, and let's move ahead for concatenating objects. So concatenate function in Pandas does all the heavy lifting we want to we do when concatenating two data frames, whether it is um, and parallelly what it does is it performs optional set logics, like whether it is union or intersection of the indexes, if there are any indexes. And so first of all, what we will see what does concatenate function do in the simplest form of it. So we are here, as we can see that there are three data frames: df1, df2, and df3. When we concatenate all these data frames without any parameter extra parameter given, it concatenates all the data frames one by one, just stacking one below another. Okay, so let's move it towards the coding part. And here, as we can see that we have provided three data, we have defined three data frames. Sorry, my voice is breaking, I think. So here there are three data frames provided: df1, df2, and df3. Okay, so as if we want to print df1 df3, then we can see that it has a8 and b8 c8 in columns, in respective columns. And now what we will do is, like, we will store all the data frame names in a list. Okay, frames is equal to df1, df2, df3, and now we will concatenate these data frames into a result data frame. That is what, here it is. And now we will print a result. As you can see that result data frame is exactly as this data frame. Okay, a0, a1, a2, a3, and a4, and something like that. Okay, so this now we will go through the original concatenation function. Like, it's the sibling functions, like numpy dot concatenate takes a pandas dot concat also takes a list or dictionary of homogeneously typed objects, and concatenates them with some configurable handling of what to do with the other access. Okay, so this is our fully functional concatenate function, pg.concat, and there are some parameters given inside the function, and we will be passing these parameters as values. Okay, so let's talk about all the parameters one by one. Objects. This is a sequence or mapping of a series or list of data frame objects. If a dictionary is passed, the sorted keys will be used as the keys argument unless it is passed, in which case the values will be selected. We will be seeing this like later. And any non objects will be dropped silently unless they are all none, in which case a value error will be raised. And there now the next parameter is axis, which is by default set to 0. Otherwise it is um, it defines how we are going to perform concatenate function, whether it is rows or columns. And now the next parameter is join. That is by default it is set to outer. Otherwise we can define it inner 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 for intersection, and outer for union. Okay, So and the next parameter is ignore underscore indexes. Uh, it is a boolean parameter. By default, it is set to false. If it is set to true, then index values on the concatenation function it are dropped, and then the resulting access will be labeled labeled as starting from 0 to n minus 1. And this is useful if you are concatenating objects where the concatenation access does not have meaningful indexes operation. Like we are concatenating two data frames where the first data frame has some useless indexing, and the second data frame also has useless indexing. Then we can define the new data frame by dropping the indexes, and then we can do we can do the new indexing keys. It is also a sequence, and by default it is set to none. It constructs a hierarchical indexing using the passed keys as the outermost level. If multiple levels passed, this should contain tuples, and all the other things don't matter. If you want to you want me to explain these all these things, then I can explain, but it is not important at all. So let's so without a little bit of context, many of these arguments don't make such don't make such much sense. So let's revisit the first example we did. The very first example we did in this video, and then we will be like printing the result. So this is result. We are concatenating our data frames, and we are passing keys. That is, we are just trying all the parameters one by one. So okay. So in this code, we have passed three keys. That is, we have three data frames, and we are passing three keys. So let's try what it prints. Okay, and now we have result, and we'll just print the result. Okay, and we can see that x the first key has been passed to the indexed to the data frame 1, that is first data frame, and the y has been indexed to the data frame 2, that starts from here, and the value z has been passed indexed to the data frame 3, that starts from here. And for example, we can, and based on the indexing, we can slice our data set like this result.loc, and then we will just pass the index, and now we can print our data frames, and that is originally our data frame 2. So we should note that like concat and append makes, and therefore append makes a full copy of the data, and that constantly reusing this function can create a significant performance hit if you need to use the operation over several dataset. Use a list comprehension. Like, it is just saying that if you are using more than 3 or 4 data frames, then just make a list of the data frame names and use them. Okay, so now we are going to try something else, that is like we are going to try joins. Okay, so let's define a new data frame 4, and let's print it. And now what we will be doing is we will be concatenating data frame 1 and data frame 4. Let's try it, and it will be done on x is equal to 1, and as we told you that by default join is equal to outer is set. So here we will be like performing outer join, that is union of two data frames, and let's just print the result data frame. Okay, so as we can see here that these two rows are the common rows between two data frames, and the first uh, the first two rows are like the um, first first two rows are like data frame 1 contains the rows, but data frame 2 does not, and last two rows are like data frame 3 contains rows, 1 does not contains rows, and data frame 4 contains. So that's how like our union works. Okay, Okay, so now let's just try our inner join in our data frame and print the value. Okay. Okay. Okay, so and just do it. So here it is, like result is equal to pd dot data frame and pd dot concat, and our data frames have been passed, and join is equal to inner is set, and x is equal to 1 is set. So let's just set the like print the result, and we can see that now our result data frame contains only common values between two columns, between two data frames. So that is how we do. Okay, and now we can just suppose that we just want to reuse the exact index from the original data frame. Okay, so we will just um, what we will be doing, like we will use the indexes from the df data frame 1, and then use those indexes to reindex our result data frame. Okay, so that is what our data frame is going to result data frame is going to contain. Hmm? As we can see that original data frame df1 contained like indexing, and now we can print the data frame. And this can also be done by like first we can index our data frame, and then we can use the concatenate. Okay, so that can be like can be done like pd dot concat concat, and in bracket df1 comma df4 dot reindex df1 dot index comma x is equal to 1, and just write. Okay, as we can see that this line of code and this line of code produce the same output. That is what we wanted to do, like we have done the same thing using two approaches. That's it. And now what we will be trying here is we will be trying the ignore underscore index parameter in our concatenate function. Okay, so let's just try. Okay, just a minute. Yeah. For the data frame object which don't have a meaningful index, we would like to drop those indexes. So for that what we will be doing is result is equal to pd dot concat, and then our data frames df1 comma df4, and then comma ignore underscore index ignore underscore index is equal to true, comma x is equal to 1, x is equal to 1, and that's what we will be doing. And now let's just sorry, and now let's print the result. Yeah, and we can see that we have dropped the indexes, and now the new indexes have been defined to the to our new result data frame. And let's try new. And now what we will be doing here is like we will concatenate with the mixed n dimensions. You can we can also concatenate a series and data frame objects, series and series, and a data frame and series. So the series will be transferred. First, what we will do is series will be transferred to data frame with the column name as the name of the series. Okay. So let's define a, I'm sorry, s1 is equal to pd dot series, and we'll just define a random series x1 x2 comma x3, and x4, and its name will be defined as x. Okay, and then we will concatenate it with the we will concatenate this series with df dot sorry pd dot concat we'll concatenate this series with the data frame 1. Okay, df1 comma s1 df1 comma s1 and x is equal to 1. Okay, now let's print result. See, as we can see that this is our data frame 1 and this is our series, and both both data frame and series have been concatenated based on like the new column has been assigned as the series name. Okay, so since we are concatenating a series to a data frame, we could have achieved the same result with the data frame dot assign to concatenate a arbitrary number of pandas objects data frame or series use concat. Okay, awesome. If unnamed series are passed, then they will be numbered consecutively. For example, if we are like we pass we we define a new series s2 and we with the no name, and we concatenate this series with the data frame s2 comma s2 sorry, s2 and s2. We have concatenated the series s2 three times, and let's see what is our result. Okay, so this is what happens, and our our new columns have been named with the numbers. Okay, so now if for example we want to like drop indexes, we can just pass indexes as well, but we will be doing this with sorry um, with this line of code, and we'll just ignore the square index is equal to true. Okay, and now let's print the result. See, so here indexes have been dropped, and as you can see that indexes have been dropped. Yeah. So but now we will be doing more concatenating with the group keys. Okay, so just yeah, here a fairly common use of the keys argument is to override the column names in when creating a new data frame based on existing series. Like when we concatenate two or more than two series, and and we pass keys, then those keys are defined as column names to the resulting data frame. Okay, so let's try that. And s3 s3 is equal to pd. We define a pd dot pd dot series in bracket 0 comma 1 comma 2 comma 3, and name is given id key, and s4 is also same with no name and s5 is equal to pd dot series in bracket 4 comma 5 sorry 4 comma 5 comma 6 comma 7. Okay, and now we will try to concatenate all these series into one data frame. Okay, and just s3 comma s4 comma s5 comma x is equal to 1. Okay, and as you can see that so when we do this, our data frame contains like the first one contains name that has been provided to the series, and second to the last two columns are just numbers, and when we pass keys to this code, keys to this data frame, like keys is equal to x1 and x1 comma x2 comma x3, and we will just see that all the columns are renamed with x1 x2 x3. See, that is what keys do when we are concatenating series. And let's try passing these keys to the data frame, when we concatenate data frames. So we will just go above, and that is what happens when we concatenate data frames with keys. Yeah, yeah. Here, just indexed to the like respective data frames that are given in order. Okay, we can also pass a dictionary to concatenate, in which case the dictionary keys will be passed as keys, and those keys will be indexed to the data frames that are passed in the values. Okay, so we will just try that so that you can have an understanding properly. Okay, so we are defining a dictionary x1 df x comma df1 and uh, y as df2, and then z as df3. Okay, now let's just concatenate this is. Okay, and just print the result. That is what happened when we did this, like doing this thing and doing this thing are same. So that is these are different ways to do the concatenation, and we can just uh, yes. And so multi-index created has labels that are constructed from passed keys and the index of the data frame pieces. So I think that is all about this is all about concatenating two or more than two data frames, and if you have any doubt or something that I can do to improve this video from the next time, you can comment below. And if you have enjoyed the video, please subscribe to my channel and help me grow this channel. Yes, thank you.